Good afternoon. Welcome to Resourceful Materials and our last session and best session of the day, how to make a circular economy work for cities at the scale of cities. I'm really excited about this session because the speakers here all know what they're doing. They're all experiencing the challenges and opportunities that a circular economy presents us at the scale of cities. So without further ado, I'm going to introduce our first speaker, who's Marco Abdallah, Head of Engineering at Dreesen Sommer. Marco is heading the engineering in London and has lived and worked in different cities around the globe. He's an advocate of sustainability and circular engineering and sees his mission to applying the cradle-to-cradle principles to buildings, which is, I think, a lot of us feel that way inclined. So welcome, Marco.
It's a pleasure to talk about circular cities and cradle to cradle, because we believe that's the next big revolution in the construction industry. My name is Marco, and I'm a mechanical engineer with a very strong passion for sustainability. And I work for Dreesen Sommer since 9 years. My journey started in Stuttgart in Germany. I then moved to Shanghai, China, where I stayed 5 years. Recently came back to Europe and found my place in London, where I'm now heading the engineering department. Dreesen Sommer, in a nutshell, we celebrate our 50th anniversary this year with 3,800 colleagues around the globe. And our focus is really sustainability consulting, engineering, and our mission simply is to drive innovation topics from smart buildings, circular economy, and zero carbon, and to bring that knowledge in a practical way to projects. When I came back from China in 2018, we recognized a huge momentum on sustainability, mainly driven by grassroots activists. The new generation has woken up and recognized that they are going to inherit a planet which is damaged by previous generations. So it comes that we have the Extinction Rebellion here in London in front of our doors. And that created a lot of public pressure, which starts now to influence the decision-making process of investors and generally in the real estate business. And I think that's a very good momentum which we want to use to improve the footprint of our construction sector, because our buildings are responsible for 33% of the carbon production. At the same time, they consume around 30 to 40% of the total energy we use. So it's fair to say that we have, in the end, a climate change and energy problem in our real estate sector. So, triggered by that, I think the most used word last year on real estate conferences was carbon. Also, we did a lot of life cycle carbon assessments, and that showed really some interesting results. I would like to show you a case study of a typical tower we analyzed in the city of London. And when we speak about whole life carbon, we always have to look into the operational carbon emissions plus the embodied carbon emissions. And such a tower has around 50 to 65% operational carbon emissions over the entire life cycle, and around 30 to 50% is embodied carbon. So if we speak now about zero carbon building in operation, we only tell half the truth. We forgot the large side of embodied carbon. At the point when we finished the construction of a building, we already emitted 75,000 tons of carbon, which you would need to run 21 windmills for 1 year to compensate that, just to give you a scale. The operational carbon side is around 7,000 tons, so you would need to keep 2 wind turbines running over the entire life cycle of a building. So that embodied carbon is the biggest challenge we currently have, and it's mainly emitted by the core and shell of a building, which is defined by the architecture. So we believe that one of the biggest tasks of the architecture in the future will be to reduce embodied carbon. And logically, it would mean that we start to use less materials, or we look into an alternative, which brings us to the topic of circular economy. Because if we recycle or reuse parts of our buildings, we skip the entire emissions which are related to the raw material and mining process, which is incredibly energy intensive. So now to get the full picture on our footprint, we have to look also into the material side. And we will recognize that our buildings consume around 50 to 40% of raw materials. And what goes in has to come out at one point. Our buildings at the same time produce 60% of our total waste. So we also have a material and waste problem. And unfortunately, most of that waste is going to landfills, 37% on a global perspective. Around 31% is openly dumped. 11% is incinerated, which is not good. And only 19% is currently recycled or composted. So it's cradle to cradle or circular economy, which is the most effective solution to reduce embodied carbon, and it's the solution to avoid waste. Because it simply means there is no waste, there are just nutrients. And that also means that the past quest for efficiency is also not the right solution, because we do the things still wrong, just less wrong. So what we now want to promote is a new, more disruptive approach to do the things right from the beginning. And I think that's what we need to tackle our global challenges. So our mission is now to move the construction industry from linear economy, make waste, to circular economy. And when we started to do that, we recognized that we don't have the knowledge to do that. Because when you want to work on materials, you have to look into the chemistry, you have to look into the ingredients of each product, and therefore you need chemists. That's why I, as a mechanical engineer, and also architects, they don't have that knowledge. We need to have chemists. So we merged with the company EPEA. EPEA was founded by Michael Braungart in 1987. And they built up an incredible knowledge on circular economy, on developing products. And also, I think the Ellen MacArthur Foundation visited Michael Braungart, and we're now the biggest supporters of the movement in the UK. And we believe that together with the knowledge of EPEA in Cradle to Cradle and circular economy, and our knowledge in real estate, we have a very good solution to approach large-scale problems. When we talk about Cradle to Cradle, we don't want to be reduced on a material science. It's much more. We want to create buildings with a positive footprint, and therefore we use the two cycles, the biological cycle and the technical cycle. A great example is the RHE project in Germany, where we use that technical cycle to develop a new facade. And that new facade was driven by the idea of design for disassembly. So the facade can be 39% recycled or even upcycled, and 61% is downcycling. And that advantage gets really obvious when you compare it to a conventional composite insulation solution, which is 20 layers of materials glued together to one piece, where you can't recycle more or less anything. You downcycle most of the material. You send 31% to the incineration plant, and 8% go to the landfill because they are full of pollutants and can't even be burned anymore. We document that in a building material passport, which is for us also the most important tool to design and develop a cradle-to-cradle building. And in the end, it provides proof. It provides transparent facts. And if we discuss now with investors, they recognize that a building without such a passport is a black box. And if they want to sell it in 5 or 10 years, they will compete with cradle-to-cradle products, and they will have a big disadvantage. Buyers will ask for that in the future. It's the equivalent for the energy performance certificate. Now, since most of our buildings, especially in the UK, our cities, they consist of existing buildings, and the buildings are full of raw materials we actually could use. We now try to promote that principle of urban mining on our renovation projects. Because why should we now go to the other side of the world, dig into the ground, get out raw materials and bring them to Europe to make a new building when we have the same resources in our landfills, in our buildings, and in our urban environment? A great example is the World Trade Center in Brussels. It's 110,000 square meter of area which is going to be renovated, completely stripped out, including the facade. And that's a lot of waste. And for us, it's a lot of nutrients which we want to use when we renovate the project. And therefore, we made a cradle-to-cradle check at the beginning of the project to assess what kind of materials do we have in our building. Are they recyclable? Can we reuse them? We did a full inventory of the existing materials and defined targets. And one target was to maintain and reuse 63% of the building in terms of weight. We want to reuse 0.6% off-site and recycle 31%. And waste disposal is 4.7%, because you can't, when materials are polluted, you can't reuse them and you can't recycle them anymore. The new materials which we're going to use in that project are cradle-to-cradle materials, so we want to have a fully circular building at the end when it's completed. That's how it looks like on site. Up to now, we evacuated 1,600 tons of materials from that project, which is reused on site and in other locations. I think there is no other project in the world which has so much materials going to a reuse stream. We reuse tiles and panels in the same project. The funny thing was the tiles you see on the left side are incredibly valuable. An Italian manufacturer came and said they are not produced anymore. They would pay us 150 euros for 1 square meter of those tiles. We wanted to keep them. Now we have them, we use them in the lobby because you can't buy them anymore. We reused the raised floor in a project in Paris, which we also do. We reused the carpets in another project down the street, and the ceiling tiles are refurbished or refabricated by the supplier and also reused in new projects. So it is a big effort to do it. It is a lot of logistic works you need to do. You need to find spaces to store the materials. You need to develop demolition strategies. It's a project management task in the end. And the reason why it's a big effort is because we didn't design the building as a cradle-to-cradle building from the beginning. We don't have a building material passport, so we don't know where the buildings are, which we can recycle. And that makes it so difficult. And that's what we want to avoid now in future projects. So we promote very much the topic circular fit-out, and because we believe that fit-outs are a great starting point. The lifetime of a fit-out is only 5 to 10 years, so there is a huge turnover of materials, which provides us a huge potential of circularity. And I think one great example is the town hall in Venlo by Cravanger Architects. They have an extraordinary interior which is extremely healthy, because one prerequisite of cradle-to-cradle is that materials must be free of pollutants. And so we have additional, I think they installed green walls which can purify the air, furniture which can be disassembled and recycled, biodegradable rubber wood, and carpets from ocean mining. So it was, I think, implemented very well throughout the project. I would like to close the presentation with the last slide, which shows you the cradle in Düsseldorf. I think an extraordinary project because it shows that a sustainable building does not need to be a box with green walls. It's won several awards on the MIPIM last year because it is a cradle-to-cradle project. The key strategy here was to have that exterior timber structure which can be disassembled from the facade, from the concrete slabs. And for us, those awards were the sign that we were on the right track, and it has already started. And if we now think and we now start to design and build buildings, we see it as a heritage to the next generation. And cradle-to-cradle can't be retrofitted, so it's actually now the time to do the right things. And I personally believe that it provides such a nice task to architects and engineers to think outside of the box, be creative, develop new solutions, and at the same time you can make an impact on a global challenge, which for me was always the reason to become an engineer 12 years ago. Thanks for your attention.
Thank you, Thank you, Mark. Thank you, Marco. Thank you, Marco. Brilliant. Thank you. If you could step down. I said it was going to be good, so that was brilliant. Could we have our next speaker, please? That's Roland van Delden. He's the founder and CEO of LEDX Innovations, a developing and manufacturing company of circular building materials based in the Netherlands. Thank you.
Does this work? Okay. Good afternoon, everybody. My name is Roland. I'm the CEO of Bitufa and LEDX. Bitufa is a manufacturer of bituminous waterproofing membranes, company that we are running already for 40 years. And as you may all know, bitumen is a fossil raw material, and bitumen is not allowed to be used anymore in 30 years. In 2050, in Europe, it's not allowed to use fossil raw materials anymore. So that's why we said in 2014, let's try to do something with the waste of today, and let's develop something where waste can be used and waste will never come back as waste. Sounds a little bit complex, but it's not. And we said, okay, what kind of waste shall we use? And the waste that we're using is polyvinyl butyrol. And I never heard about polyvinyl butyrol. It's the film that used to be in our safety glass. We all have a car, and the car has a windscreen. And if we go to car glass for a new windscreen, the glass is coming on a pile like this. And then there are companies that take off the glass of the lamination, and that glass is used for new glass. And nobody knows what to do with the film which is in between. So that means that all that film is being buried or burned. And that is our raw material of the membranes that you can use, buy with us already. And the good thing is there is over 3.5 billion pounds of this raw material available in Europe. Imagine how much there is all over the world. Polyvinyl butyrol. And what we are doing with LEDX, we are making durable membranes out of waste. They are all designed to dismantle, and they make sure that carbon reduction is also inside, but I'll tell you a little bit more about that later. So the first product that we introduced to the market is LEDX, the new LED. It's a membrane that can be used in buildings for flashing. So if you have a little bit time, come by and see us. Here around the corner, there's our booth. So LEDX is a replacing material for LED. And I suppose we all know where LED is being used in our house. There are 10 to 12 different applications of LED, but LED is also dangerous. These are a few pictures of the application of LED. And last year we've seen how bad LED can be. When the Notre Dame burned down, complete Paris was buried with remainders of LED, creating big problems. But another disadvantage of LED is also that it's being stolen. And then we have to replace it with LED and it's stolen again. So it's very good to have an alternative which will not be stolen. The membrane that we developed is recyclable. It's also designed to take apart. I have a nice picture here. After the lifetime, which is 30 to 40 years, we can dismantle the membrane, separate the polyvinyl butyrol that we used as waste, but we can use it again as the raw material, and the aluminum can also be reused. At the moment, we are selling this very green recyclable membrane already in 15 countries, and our mission is to ban LED out of all our houses by 2030. But if we replace all the LED in the world by LEDX, we still have 95% of our pile of waste available. And that's why I'm happy to introduce to you something new. There's a small movie. This year, we are coming up with LEDX circular roofing, which enables us to replace all the flat roofs in the world by waste. So, like Marco said, maybe this is one of the very easy to use applications that we all need to do to get a little bit a better world. And we are very excited about this new product. It's for flat roofing, single ply, very wide, reflective, very durable, and of course recyclable again after the very long lifetime. Made out of waste, reflective. Now this is what I said already. It's a huge market. 1.2 billion square meters of LEDX, of roofing are being used every year. And how nice would it be if we can replace all of that by our waste membrane? Of course, I need help of all of you because we cannot do it alone. There is a huge carbon impact on carbon reduction on working with our LEDX membrane. And I have some referring figures. If you use a bituminous roof, there's 13.2 kilograms of CO2 emission per square meter. There are also friendlier products, but on average, a roofing membrane has 9.42 kilograms of carbon emission. The greenest roofing membrane that is available in the market has 5.41 kilos carbon emission at the moment, and LEDX has only 1.10 kilos carbon emission per square meter. So while using LEDX, you can also do something good for the world. If we put it in a metaphor, if you have a roof of 750 square meters and you put LEDX roofing on it, it saves as much carbon emission as every individual is giving. So for us, it is, let's say, very important that the design of our circular products is very well. We have to look at the raw material cost price, and we all know that waste is very cheap, and we are happy with that. To be successful, we need to be able to scale up, and of course you need to have the money to put factories all over the world and the organization, and that's not easy. For us, the next challenge is to open factories, let's say, at the big cities everywhere in the world. So we are planning to open 6 factories in Europe the coming 3 years, and after that we will expand to China, to India, and to Indonesia. And the good thing is, locally we are reducing waste because we are using the waste as raw material. It also means that the raw materials are not needed to make the membranes, and we're creating a lot of jobs. So it's a win for everybody. If you say, how does that circular economy work for cities? I would say, come by, just buy our membranes, and if we do that together, it already works. So, in that, what I mean, step by step, we can use the waste of today and to prevent that global waste is coming back. Thank you very much for your attention.
Thank you, Roland. Nice and specific in detail. Thank you. Our next speaker is Cecile van Oppen. She's the co-founder of Amsterdam-based consulting firm Copper8. As a professional, she has been active in accelerating the circular economy and circular construction for over 10 years. Convinced that a transition to circular thinking requires the rethinking of traditional building models, with Copper8, she wants to develop a new norm for consulting businesses. Thank you.
Is this working? Yes, perfect. Sorry, I like to walk, so I don't want to stand there. Hi, I'm Cecile, like Duncan said, and I want to share with you my perspective on how we can make the circular economy work in cities. As Duncan already said, I've been working on the circular economy for over 10 years. It all started with this beautiful building over here, which is actually a housing project by a housing corporation in the Netherlands. And it actually ties very well in with the story that you've been telling, Marco, because back in 2008, they wanted to do a climate neutral demolition and rebuilding of this project. And it was about 400 homes. And me, as a sustainability fanatic since I was young, was thinking, how come this is sustainable if we call it climate neutral, but we're only looking at the energy perspective and not looking at these materials? Why are we demolishing at all? Unfortunately, it was very difficult to challenge the demolition question because the social cohesion in this area was very, very bad. So they decided to demolish it, but we managed to actually say that we wanted to return 95% of the materials of the demolition back into the new project. And we managed to actually make that work. We've done several other projects since, including this lovely building by Alliander consisting of 82% waste, if you will. But I was asked, of course, to talk to you about how do we make it work in cities. And tying back to the talk that Roland just did, you know, if we look at products, it's fairly, I'm not going to say it's easy, but it's a little bit easier to make a product circular. But when you're looking at a system as large as a city, it is very complex because there are a lot of actors. These actors have own opinions and you need to engage them in order to actually move into the right direction. The impact, of course, is huge if you actually manage to get all these actors moving in the right direction, but it comes with a lot of challenges. When I look at the potential that cities have in creating the circular economy, there are lots of them. Procurement is one that I'll go into in more detail in a little bit. Land allocation contracts, trying to give them only to circular companies, to organizations that actually want to make a change. You can look at activating residents in Rotterdam, and I think Metabolic actually worked on this. They have this lovely gold transport, so they've actually painted all of their waste trucks gold and communicating to their residents, we're transporting gold here. You can initiate sectoral initiatives. Amsterdam looked at trying to move the hotel sector forward in the city. You can provide subsidies. So Amsterdam also, together with a number of other cities in the metropolitan region, if you'd like to call that in Amsterdam, it's a little bit difficult saying that here in London, but provided subsidies to really stimulate entrepreneurship in the circular economy. And I'm sure Christian will mention that a little bit later. Also coordinating resource flows, and I'm sure both Metabolic and EME will discuss that. And of course, there's also the topic of regulation. But when I look at these topics, they're actually increasingly difficult from top to bottom. And that's why I want to talk to you about procurement, because it's actually fairly easy. First of all, I want to ask you, and I realize it's a little bit difficult to get answers here, but how much money do you think European governments, so national, local, everything, spend every year? Billions, billions, trillions. Well, I actually have difficulty, how much is this? I think this is 1,800 billion. This is the amount of money spent by European governments, and I'm sorry for other British people here, but you were still included in this last year. This is how much governments spend. And when we can use that purchasing power to actually create a circular economy, buy LEDX products, create circular buildings, we have a huge potential for change. And I really think that's important because I put this funny cartoon up, but I think governments should really take the lead. They need to not be hypocrites. They need to show, not only by saying, you should all be circular, but no, I'm going to also be circular. I'm going to show the people who work in my government what circular is by city halls like Venlo, but I'm also going to show residents in the city that we're going to actually create this change, but through procurement. And I want to ask you one question now again. Sorry, I have lots of questions, but we'll do a hands up, hands down thing here. Fact or fiction? Fact can put the hands up and fiction can leave the hands down. Do you think that European tendering laws are limiting for circular procurement? So if you think this is true, you can stick up your hands, and if you think it's false, you can leave your hand down. So 50-50-ish. People in the back luckily think it's fiction. I actually think it's fiction. I think there are very little limiting factors in European tender law to actually create the circular procurement. It is more a behavioral issue. It's not a matter of can I, it is a matter of do I dare to actually make the decision to ask a different question. And I'm going to make it very easy. We wrote this book. It was recently translated. I have a couple of copies with me, whereby we actually want to share the knowledge of how do you procure circularly in 8 steps. And I'm going to make it very easy because I can talk about a building, but a building is hugely complex. I'm going to be talking about a bike path, and I'm going to be talking about 3 of the 8 steps. First of all, selecting the product group, and this is actually also the reason I've chosen to talk about a bike path, because what we've done, for example, for the city of Amsterdam, is to look at the expenditure that they have in terms of procurement. So we looked at everything that they're tendering in an entire year, and we've also looked at the potential impact that those tenders can have on sustainability. And all of the tenders that are up here actually have to do with infrastructural expenditures, roads, bike paths, and potentially also buildings, but sometimes they're actually found here. So a lot of the spend that you can make a huge impact is actually infrastructural. So what we then did is we didn't say, you know, we have this huge technical set of requirements in the Netherlands that are almost seen as law, but they're not. And what we did is we said, you know what, we want you, dear sector, to work together with someone who's an expert in biodiversity, someone who's an expert in circular design, and a contractor. And we want you to provide us with the design, we want you to build it, and we want you to maintain a series of bike paths for about 20 years in the Port of Amsterdam region. So it's a part of the city of Amsterdam. And we looked there not only at circular materials, because it's very important, but as Roeland also said, circular design is very important. And in the Port of Amsterdam region, there are a lot of, there's actually a lot of construction work being done. So there's a lot of water and energy transportation. So what is really important that it is that you can actually take the bike path apart in order to reach the infrastructure that is under the bike path. That's why circular design was important. But also by creating a bike path, you decrease the biodiversity in the area. So how can you compensate that? So we looked at all these different aspects, and the eventual result was this zipper path created by Schagen, whereby they said it is actually a fixed bike path when we first build it, but it's very easy to take it apart by just dismounting pieces of it. Then you can go underneath, reach all the energy and water infrastructure that you need to reach. And by doing so, we've actually created a hugely circular bike path. They're also looking into using bio-based paints to make these I don't know what they're called, but signages. And it's a very easy way of actually making sure that people start thinking circular. If we just looked at the technical requirements that are always being asked, we would never have gotten this answer. So dare to ask a different question. And then how do you secure circularity? Because that is another point. Very often, people that I speak with are a little bit hesitant because they say, oh, you know, it's beautiful that you're telling me that I should ask a different question. But then all of these suppliers will promise me lots of things, but then when it comes to the realization phase, they're not going to actually make it work. But there are actually very easy ways of making that work. So one thing that we did is we said, okay, we'll give you a framework agreement of several different projects. Because by giving you a framework agreement, you actually have room to do some R&D, financial room, because you have the commitment of a long-term agreement. But, and that's the second point I want to mention, if you do not actually meet the promises that you've made in the tender, we won't give you the other projects. And that is completely allowed in European tender law to do it this way. And finally, also look for win-win solutions, because you don't want the suppliers to be doing all of the investments and not making money, because they need the money to invest in all of this R&D. So this is a very simple project. I have a lot more in difficult sectors like electronics, in buildings, and everything. But the one thing that I want to share with you today is that every time that you spend money, and that is as an organization, as a government, but also as an individual, you are casting a vote for the type of world that you want. So let's use that money to create a positive change. Thank you.
Round of applause, please. Thank you, Cecile. That was amazing. So, could we have Gerard Romers of Metabolic? He leads the cities team in Amsterdam and applied research lab focused on building a sustainable and circular economy. Working with cities and regions across the Netherlands and Europe, Gerard specializes in urban and regional metabolism analysis.
Thank you. Is this working? Yeah. Great. All right. Cecile, had je ook een klikker? Great. So what I'd like to discuss with you all today is a particular stream of materials and products in the built environment. To show you at a city scale how we can unlock the urban mine. I have a background as a spatial planner, so I really like to look at the problem or the challenge, if you will, of circular cities, also at the scale of cities and neighborhoods rather than just the building level. And I think this provides a really nice insight in the type of approach that is also needed if you really want to make structural change in a big sector and at the scale of a city as a whole. And it provides also a good way of showing how we work at Metabolic. Metabolic is an engineering firm, consulting firm, and what we do is very often related to quite some data crunching and quantitative analysis, but all of that is always as a basis for strategies that are aimed at implementing change on the ground, and this is one illustration of that. So I've taken the liberty of using a product of Duncan's actually as an example. We all know what the core idea is behind a circular construction sector or behind a circular building. A circular building is designed from either secondary materials, so materials from reuse or recycling, or renewables, in my opinion, maybe wood, for example. At a building level, I can draw up quite a range of really nice projects, but each of them really require, and I think Duncan will testify to that as well, quite a bit of persistence, ingenuity, a lot of energy to get them off the ground. I think the waste house that Duncan has built in Brighton is composed of 85% of renewable and reused materials. But that's not a scalable model in and of itself. So what we'd like to see is that in terms of a circular city, materials are actually coming from the urban mine. The existing built environment, whether that's buildings or infrastructure, should really be harvested, so to say, to get the materials that we need for our buildings in the future. And in that way, of course, ultimately the goal is not recycling or reuse for the sake of reuse, but a mitigation of the environmental and carbon impact associated with those materials, like Marco already mentioned before as well. Sadly though, high-value reuse of construction materials is quite rare. The building sector is famous in the Netherlands as well as across Europe for actually recycling quite a few materials, but a lot of those are recycled at low value, for example as road fill. And the percentage of materials that's actually recycled at equal or higher value than their original function is in the single digit. 2, 3, 4% of the materials are really kept in the loop in the way that we would like to. So I want to talk to you a bit about what's holding back the scale up of this type of high quality reuse in urban mining. And I'll do it from the perspective of 3 actors in this field, the first of which is an architect. If you want to do circular building design, this is really difficult. The reason for it is that including secondary materials is a really complex and costly process because the location and time at which these materials become available is often unknown. We don't really have a good central database or map to refer to see what's on offer at the moment that you want to build. And if we can find out where we can maybe harvest sustainable or circular materials, this information often comes too little too late. It's really difficult to design at the last moment. It's really difficult to coordinate between a demolition project and a new build construction project if you only have a couple of months. Ideally, you want this information 2 years in advance, and you want quite a predictable and reliable source for it. I know architecture firms that do this, so I've taken the liberty of adding an example from an architecture firm called Superuse in the Netherlands, and they are actually using a dynamic definitive design. So it's the word says it already. They continuously shift, whether it's from their sketch design, preliminary design, or definitive design. All of it stays open as much as they can. They try to lock in the sourcing and the materialization of their design as late as possible, because it's really difficult to plan ahead. But of course, this is not the ideal situation, and it can get you really interesting and creative building designs, like this waste processing station in The Hague, which they designed, which is actually made from waste. You can see the plating also on the facade from steel industry residual products. But creative and nice as that is, it's difficult to scale it up. Another problem is that although governments really want to set clear and ambitious targets for the circular economy and for the circular construction sector in particular, it's very difficult to know what's realistic and achievable. Here's an example of the Dutch government that has recently said that the construction sector in 2030 should halve its use of primary or virgin materials. But how can we know whether that's possible? How do we know whether that's achievable, even if we try our hardest? And maybe what's more, how can we, as a government, also plan and facilitate urban mining if we don't know the type of urban mining and the quantity of urban mining that will take place in the future? These are really difficult questions. As a supplier of building materials, and maybe if you have ambitions to move into circular building materials like Roeland, this is a risky investment at the moment. It's difficult to predict what materials will be released and what you can work with, and it's also difficult to predict at the moment the demand for these types of materials. So if you want someone to invest capital and time and energy into a circular production system, that also requires a lot of information that at the moment we don't really have at our fingertips. So we thought about this quite a bit and developed a solution that I want to share with you, which is an urban mining tool. Basically, it's a model of the urban mine that allows you to, that provides insight into mass and the volume of different materials. It also provides for over 150 products in the buildings an overview as well of what is actually stored in the built environment. And it provides an idea of the value financially, but also the environmental impact that is represented by these materials. It allows you to really model the materials that are inside different building types. For now, we've restricted this to housing and utilities, utility real estate. And it allows you to map those materials in space and in time. And we think that that's the type of information that you need if you really want to scale up urban mining activities and make it mainstream rather than the exception. As a basis for the model, we've actually used building inspection data rather than architectural designs, because that was the best way to get information about existing building stocks, also when they were developed and designed further back in the past. And of course, those are the buildings that are going to be demolished or refurbished and renovated the soonest, so they are the most interesting for us. And we've done that together with a partner, SGS Search, whose core business it is to do these inspections. So that was a really important source of empirical data. Then we've coupled those references to spatial data that's public in the Netherlands of the location and type of buildings that you have. Basically, you have a big geospatial database for the whole of the Netherlands that allows you to project this data on it. And we work with governments and also Economic Research Institute to predict the changes in those building stocks, to predict what is going to be demolished, how much new construction is going to take place, which part of the building stock is going to be renovated. And of course, by coupling those types of activities to the existing building stocks and the materials within it, you can start predicting the material flows in the sector as a whole. Now, obviously, one thing you can draw from this model is a static map. So here I've brought an example from the city of Amsterdam. You can see the channel belt. You can see the channel belt there also on the right. And you can say, for example, on the left, where is the most steel in my city? Or on the right, where can I find the copper stocks in the built environment? But that only gets you so far. And what is more interesting is to see whether you can predict the development of supply and demand in the future, because that also allows you to anticipate on these developments. And that's what we've tried in the city of Rotterdam with Superuse, so the architecture firm that I mentioned, and a host of other parties. Blue City, which is a circularity incubator in that city, and also the city of Rotterdam supports this project. And we've analyzed, or we tried to gather information about as many demolition and construction projects as we can. This is ongoing, so the first round of data collection was actually more difficult than we thought, especially with regards to demolition. But based on the permits that the city hands out for demolition and construction, we could already locate over 200 demolition projects and over 4,000 construction projects. This is an ongoing process. But already from that we could pull out some interesting projects for urban mining and exploring the potential further. So looking at the buildings that would be demolished, we made a top 10 of the most interesting donor buildings, if you will. And those contained the majority of the materials because they were really big. The biggest project that we had in our sample was a hospital complex that was about to be demolished, and that already held more than around 16% of the materials that would be released from the urban mine as far as we could predict it. And then, it's difficult to read. Sorry for that. The font didn't go well. We also looked at not just the materials, but also the product level. So though you can't read it, we looked at window frames, steel beams, wooden beams, flooring, insulation plating. All of these products we can also draw from the model. And in that way, we could really narrow down and see if we draw from this top 10 of projects and we draw from the top 10 of the most interesting products in those projects, how can we really target urban mining, target the urban mine in a very specific and impactful way. Zooming in like that really helped us because it's only 2% of the mass of the materials that you get like this, but you focus on 10 projects and 10 product flows. But these represent over 10% of the carbon emissions in the built environment and of the embedded emissions. So it really helps if you want to make a difference in an effective and efficient way. These products have a potential financial value of 25 million euros if you would look at the new the prices for a new product. So it is also an interesting trigger for several market parties in the building chain to really start looking and see if they can mine these buildings, not just for the sake of environmental impact, but also for financial gains. Right now we're at the process with the city of Rotterdam and with a consortium of building sector parties to also figure out the feasibility technically of getting these materials out in demolition processes, the aesthetics and material requirements, and see if that includes or excludes any categories. So we're trying to really critically, from a practical viewpoint, also say, okay, we have a model, we have a theoretical potential that's really interesting, but does that hold in practice? And that can be as simple as me sitting down with 3 architects, pulling up this model, saying, okay, this is a theoretical potential that I have, but if you look at these buildings from this time and at this location, and at these product categories, do you feel that you could actually start retrieving this, or is this just fiction and a theoretical model, but doesn't it land in reality? So this is a really interesting practical way, I think, to see if we can make urban mining work at scale for the city of Rotterdam. And it also deals with the three barriers that I mentioned before. For an architect, if you use this model, you get a quick overview of projects and materials and products that might be released within them. And it really helps you to get a head start in your circular design process rather than having to anticipate in really short time spans continuously. For a government, the model can also be really handy and insightful. We used the same model for the Dutch national government in collaboration with the National Economic Institute for the Built Environment to also predict the urban mine of the Netherlands and what that would look like and how it would transform in the coming decades. Using macroeconomic models and using what they predict in terms of development for construction and demolition and the markets between them, we could see in this research that theoretically we can land this target of 50% reduction of primary materials, because though in 2014 when we did the baseline analysis, only 30% of the materials required for construction could be drawn from demolition. Because the construction will slow down and the demolition will actually speed up in the Netherlands, by 2030, theoretically the maximum is 60%. Of course, if you then do a practical test, that will be slashed in half at least by my estimation. So this also shows that although theoretically you can achieve it, circularity is not just going to cut it, and we'll need to move to renewable materials, bio-based solutions, in addition to focusing on reuse and recycling. So I think this is a really interesting litmus test, a really nice kind of reality check for setting the right policy goals that are ambitious but that are also realistic, so that you don't over-ask. And for suppliers of building materials, this can also be really valuable information because it's easier to predict the quantity of the resources that you want to use and that you want to upgrade, and it makes it much more feasible to start investing, especially because you can start predicting the evolvement of the market over time. So for us, this has been a really exciting year because we got to test our model and our product in practice, which is really nice. This also showed us that to make it even more usable and to improve the model further, what we want most and more than anything is to test it in pilots and in practice, and to test it with parties from the market through projects. So in 2020 we'll be continuing the work in Rotterdam, but we'll also be testing the model in different contexts and locations. In the Nordics, in the US, we have a couple of projects starting, and I'm quite curious to also hear whether here in the UK there might be interesting projects that we could couple to this methodology. Hopefully through that we can kind of create a learning system, and if we can enrich the theoretical potential of this model also with practical data, then it can really be a way of scaling up urban mining and the circular economy in cities. Thank you very much.
Thank you, Gerard. Fascinating as ever. We've got one more speaker, Christian van Maren, co-founder of Excess Materials Exchange, who didn't send me a biography, so I can't tell you anything more than that. Does that work?
Is it working?
Yes, that would be
good. Thank you. I'm sorry about that, Duncan. I thought maybe you could reuse last year's one. But actually, it's good to see that there's such huge interest for the circular economy in a time when Corona is sweeping the planet, with a Dutch delegation where Corona currently is exploding. So many people showing up here. You're either very gutsy or very interested in the circular economy, which I think is good news. It's good to be last because I feel like I had a great introduction to the story that I'm about to share. Maybe immediately building on Cecile's story about procurement and the role that governments can play. The Excess Materials Exchange is a good example of that, where the city of Amsterdam did a sort of a competition of inviting companies to come up with digital ideas to make circularity easier and faster, or launching it faster in the city of Amsterdam, and we won that competition together with Cecile from Copper 8 and with Alba, another company. And what we propose to do is to use a sort of a dating site approach to match secondary materials and waste and make that circular economy in cities happen. And I'm very happy that I don't have to go through all the details, so thanks for that, Marco, for giving all the background. Because we underline all the challenges that there are in matching secondary materials and matching waste. We see that there's issues in quality. It's very difficult to give off guarantees on materials that have been used. Like, how can you guarantee a certain function or a certain capability or capacity to carry weight or to perform any other function? I think it's a very interesting space for insurance companies to step into, or maybe banks to give that insurance. Timing is an issue. When a building is demolished or dismantled, as we're supposed to call it these days, the demand for the materials that are coming from that building isn't there per se. And then at the same time, quantity. When a building is being dismantled, a lot of materials are being pushed onto the market, and the market has to do something with it, but sometimes it cannot deal with those quantities. And then also location is an issue. And so the way that we've solved that is by developing a dating site where we actively match suppliers of excess materials with the buyers of those materials. But also what we do is we add what we call so-called value-added providers to that to make transactions happen. So think of logistical service providers, technical service providers, so perhaps maybe LEDX can play a role in that, in making materials available for the market, again, in a high-value way, but also law firms, governments, and Knowledge Institute. Every organization you can think of that are required to make transactions happen. And what we follow is sort of a three-pronged approach where we give an identity to waste streams using something called the Resources Passport, which these days is becoming more of a household name in the construction industry. We add intelligence to that data. A lot of that intelligence is artificial, but also some of it is not so artificial, which is just our own intelligence, so to say. And then we have a very integral approach. So we try to make the transactions that we create as smoothless and as simple as possible to take away all the excuses that people and companies can have for using secondary materials and using waste. And for that we use the Resources Passport, which is very basic. We use blockchain to store that information, which is of course a buzzword, but I think for this particular application very useful, because blockchain really what it is a very affordable or cheap way to make quality assurance and quality control happen. It was already mentioned, I think, in Marco's presentation that the availability of information is very important in making high-value matches happen. And I think the passports play a very important role in that. And with blockchain, you can ensure that the information on those passports is as correct as possible, making high-value matchmaking possible. Then we combine that with very basic marketplace functionality, which really serves as a sort of a window dressing functionality where you can see what is going on, but really all the heavy lifting is happening behind the platform, all the matchmaking where we use our intelligence and the artificial intelligence tools. But what we also do is to make decision making easier, is that we don't just look at the financial value of materials, but we also, and this is a methodology that we developed with Ernst & Young, look at the environmental impact that you can save by matching the materials on our platform. And for that we use 17 environmental indicators, and we express the environmental impact you can save in so-called eco-cost, which is a way of sort of expressing the impact that you can save for future generations in a monetary sense. So you can really compare it with the financial value of those that those materials have, or those components have. And what we also are looking at right now, and this is sort of fresh off the press, is also looking at ways how we can express the social impact of the matches that you can make. And we're now working together with a company called Pre Consultants, that are one of the foundation layers of the whole environmental and social impact quantification and qualification. And with them, we're now doing an experiment in which we're looking at some of the matches made on our platform, looking at the effect on workers in the value chain, on the users, on small-scale entrepreneurs in value chains, and on local communities. And it turns out it's actually quite difficult to quantify social impact. This is their words, not mine, but it's very difficult, for example, to have companies report on the reductions in slaves they've used in their value chain. You can talk about CO2 reduction, that's fine, but you talk about child labor and forced labor, and it becomes much more sensitive. So what we're now probably converging towards is expressing it in reducing the risk on certain events happening, like the risk on forced labor or the risk on child labor. And that is something that you actually can use to communicate outwards, but also to use in your procurement process. And when this is done on our platform, also show within your organization and outside the organization that using secondary materials doesn't only have, a pretty good financial result, but also a super good environmental benefit and a positive social impact as well. And one of the other cool things that we're working on right now, which I really love, is that we're building a so-called semantic web of the circular economy. So semantic web, or linked data as it's called, is sort of how Google works. And what you see here on this slide is a very simple example of it. It's like an orange peel. And what we describe in our databases is the orange peel as in its characteristics, in its functions, all the processes associated with it, potential actors, composition. And if we do that for all the materials in our database, and you overlay all those on top of each other, you create this huge web of interlinking functionalities, processes, materials, anything you can imagine, and it makes it much easier and faster to find high-value matches for those particular materials. But then if you turn it around, which I think is much more interesting, you can also look at the demand side. Because what we currently see is that the circular economy is very much a sort of a supply-driven transition where a lot of waste is introduced to the market and we have to find something for it. But it really starts at the design side, which also I think Gerard was mentioning in his presentation. And what you see here, very complex slide, is a selection of window sills. And all these window sills that you see here, sort of graphically represented, are also plotted on this graph in the top. And what it shows is, on a certain axis, how it's scored. So for example, length, height, but also virgin material content, recycled material content, CO2 emissions, cost per year, life cycle. And by using those metrics, or using those sort of levers or indicators, you can help designers make choices based on very different metrics than maybe they do today. So for example, if you want a windowsill that has a very low MCI score, you get this one. And then it can point directly to a certain windowsill in our database that you can find using tracking and tracing in a very specific location, maybe in a radius of 200 kilometers of where you are doing construction. Or another example of a windowsill that has a very low CO2 impact. And you can sort of give commands to this system to help you find the materials that you need based on the characteristics or based on the boundary conditions that you have in your particular design process. And by doing that, sort of this is our hypothesis as we're working on this and as we're deploying this in the market, is that you can really create high-value matches that are financially feasible and viable, environmentally sound, but also have a very positive social impact, or at least a measurable social impact, so you can do something about it. And with that, make much better data-driven decisions. And we've done that already for a whole host of materials. We did a big pilot in 2018 where we looked at 70,000 tons of materials from different industries and sectors, ranging from ceiling tiles, railroad sleepers, dynamic traffic signs, orange peels, ropes, floodlights. And we found, and actually when we did this process, it was not so much artificial intelligence, very much our own intelligence, as we may, I don't know if we can call it that, but had some good results. And we found that the matches that we made resulted in a financial value of 64 million euros per year of those 70,000 tons of material being released. An energy saving that is equal to the energy use of the public lights in Paris for 5 years, just to give it some context, and CO2 emissions equal to an average car from 2017 driving around the world 23,000 times. And also the water that you can save with those matches, you could fill 860 Olympic swimming pools with water with. So you can see that with 70,000 tons of materials, which I think in construction is not that much, the impact that you can save is enormous. And what we're looking for to help raise our AI tools, because really now they are AI children, they need data to become more mature. So what we want to ask you is give us more data, because the better our data is, the better our matchmaking tools are, and the bigger the impact is that we can achieve. Thank you.
Thank you, Christian. That was amazing. Could I ask all the speakers to take to the stage? And can I ask if there's anyone in the audience that has got a question for any of the speakers? There is one at the back. Hold on.
Hi, thank you very much. That was all really, really interesting. I've got really simple questions, really. I hope they're not too simple, but when a building is dismantled, inevitably that is a really damaging process. So how, as part of the circular economy and taking things out of buildings, is the whole process of demolition going to change? And will it have to be much more time-consuming and careful, and how will you persuade people to do that and skill them up to do that, if that's the case? And secondly, I'm just really wondering where everything gets stored. Thank you.
Who wants to go with that first? Cecile?
I would like to answer the first part of the question, but more as a hypothesis, because we've been talking a lot about the technical aspects now, all five of us. But what we really need is systemic change. And I fully agree with your statement. Don't we need to go to more careful processes? And these careful processes actually require a lot of labor, skilled labor even. And what you actually see in the current economy, at least in the Netherlands, and I think it's the same in the UK, is that labor is very expensive because we tax it very highly. So what needs to change is that we really need to rethink our tax system. It's now the case that labor is very highly taxed and resources aren't, and we need to shift that in order to actually incentivize organizations to start using labor to refurbish, to remanufacture, to really stimulate the circular economy and tax the use of virgin resources. And we're actually going to be running a pilot with 4 projects in the Netherlands to see what happens with the business case of circular construction and demolition when you change the tax rules. So that's on the first side of your question. I don't know if anyone else wants to add.
Well, I think maybe on the second part is that indeed we need a lot of new roles happening, and I think deconstruction needs to happen much more carefully, which will need maybe new technologies and new people doing it. But I think also mapping the sort of deconstructionability of buildings is also something that's very important, so you can maybe predict the investment and the people required to properly deconstruct a building. And hopefully if you start doing that, if you start measuring that, and you start maybe also expressing that in a usable way, people will start to construct buildings in a way that makes it easier to deconstruct. And of course we're faced with a huge legacy problem first, which I think will require lots of labor, which I think is good for our economy anyway. But then going towards the future, we will need to start building buildings and anything that we're building, making it in such a way that it can be deconstructed easily or easier.
Marco?
Yeah, I think we exactly had that problem in our, or that challenge in our World Trade Center project in Brussels. So we had, I think, 1,600 tons of materials, just hundreds of truckloads. And indeed, one of the first steps we made was to define a demolition strategy. You can't just put a container in front of the building and tell them throw everything in. because you have to keep the materials separated in order to reuse and recycle them properly. If they are mixed, you can't recycle them anymore. We had issues with the flat glass of the facade, so we had to dismantle the flat glass pieces and store them on site, and it's a huge amount of material, so we had to find space in the building and around the building and also off-site where we could temporarily store this huge amount of material. So indeed, exactly the 2 points you mentioned before were one of the main challenges in that urban mining project.
So moving forward, if we get the right sort of infrastructure and systems in place, what do you think needs to happen? Because you're not going to have that space on every project that you deconstruct.
Well, I think what we try now to do is that we set up collaboration models with suppliers so that when we dismantle a facade, the supplier takes the facade back. So he comes, takes it, brings it back to his factory and makes a new facade of that. I think that's where we see the future. And that's where we also see that the industry reacts. The industry has a strong interest in getting back materials if they are designed for disassembly and if they are cradle-to-cradle materials, because then they don't need to buy raw materials from the other side of the world. They can simply use that waste to produce new products, and that saves them a lot of money. That also saves a lot of energy, and that opens also new business models for them. They don't want to. They start not to want to lease you the materials. There is no point in owning a carpet, why just not renting it, and then I think the entire cycle gets completely opened and in activation from the supplier side.
I think Christian wants to.
Yeah, maybe one small addition. I think also Gerard mentioned it in his presentation. When a building is being dismantled, maybe people like us or our competitors should be involved much earlier, maybe 2 years in advance when the deconstruction or dismantling is happening. So when it is actually happening, there is a new home for it immediately, and just a truck has to stop by, can be loaded on there and go to its destination immediately without, or at least minimizing the amount and time of storage needed.
Yeah. And I think it's important to realize that at least looking at it from the perspective of supply and demand, there's not a particular reason why you'd have a whole lot of storage because, in fact, the demand for materials is much larger than the supply. So either it's feasible to reuse, refurbish, or recycle something, and we just need to coordinate it really well with a system like Christian's or with a model like ours, like to put in the data early enough into the decision-making process. Or if it's technically or financially infeasible, then it's good to know that early on as well. But then this question doesn't come around either, because you're not going to store something if you can't reuse it in a good way later.
Okay, one last point from Roland.
Yeah, with the roofing membrane, for example, we'd like to remain owner of the waterproofing membrane because that's the raw material and that's where the value is.
That'll do, that's perfect. One more question. Oh, not one more, another.
This is to Christian, to Gerard. Sorry for the pronunciation. You've both kind of given a call out for data and information and kind of internationalizing your data set. I work as an architect, and what data can we start to collect that would be of use? And is it new material data that is interesting for you, or is it existing building stock only?
Is this working? Yeah. Well, I think for the way that we work at the moment, it'd be really interesting to particularly look at the existing building stocks. There's a lot of data, like Christian mentioned, that isn't stored well. It's not like every building that we built in the 70s has a nice building information model and a material passport behind it. So we kind of need to relearn what is in those buildings, but also which elements and which products and which materials that are in it. And we kind of know that, but are they reusable? Are they interesting to harvest in the first place? Or is it something that practically, financially, technically speaking, isn't that interesting? I think that type of data, that's empirical data, that's practical data, that's knowledge that you gather through doing, learning by doing, really taking it out in the field. So for us at the moment, that's the most interesting data, to layer on a rich qualitative data set next to the quantitative model that we have, because that quantitative model is only the beginning, and to move from agenda setting and goal setting to really specific and high impact implementation, we need that practical experience and to translate and codify that.
Yeah, maybe some additions. So for us, it's, I guess, maybe 3 ways. What we would like to see is one, information coming from the existing building stock. But I think also on the other hand, what information you need to design new buildings. And then also in the middle, when do you need that information? So where in the process do you need what information? So how can we best service you, basically, to help you use the maximum amount of secondary materials as possible?
Okay, anybody else? Should we move there is another question.
I've got 2 quite boring questions. The first one was about, I think, Gerard, you mentioned, or Christian, you mentioned the problem of offering warranties. And I wondered how actually does that happen? How can, especially in London, there's a great sensitivity around specifying the correct materials for safety reasons right now. So how do you get over that? And the second question is, who pays for this? Because obviously it takes more time, it takes more labor, there's a lot more logistics, there's obviously a lot more sourcing. Who pays for it, and how do you incentivize or force that happen?
So I think maybe to answer your first question, I mean, it's very contextual, right? It depends really on which material you are reusing, to what kind of degree of guarantees or assurance you need to have. Like if it's a load-bearing beam in a very critical place, obviously it is very critical. If it's more cosmetic, then it's less so. And I think the pragmatic solution for that currently, because there's no industry for it yet, is to find very gutsy insurance companies and a constructor that is willing to sign off on it, and also probably over-design it a little bit. But I think maybe as we progress through the transition, engineering firms and constructors and also, I guess, insurance companies and banks may become more comfortable with this new reality, and also have more data to really assess properly what the risk really is. But I think I would say the question is more to almost turn around to ask the market, well, this is happening, resources are depleting, and we also see that construction waste has a huge impact and hence also a huge opportunity to do better and to help in the whole climate, what do we call it these days? Catastrophe, or what was it?
Climate emergency.
Emergency crisis, to solve it. So I think it's really also a question that those particular parties need to answer to make these things happen. And then to the other question, who's going to pay for all that, is also a good question. I think right now, in this particular phase in the transition, it's more expensive. This is also why we like to quantify the environmental benefits you get with it and the social benefits as well. So at least you know you're getting a little bit more for maybe the extra euros or pounds that you're spending. But I think it should be a mix of governments, because obviously there's a lot of public benefits coming from this. And then I think it's probably consortia of buyers and sellers of these materials of making these particular solutions happen. Because really, by investing a little bit now, we'll make a future possible that has enormous environmental and social benefits. So I think both answers is great and a mix.
Cecile?
But it's not that I disagree with Christian, but I think that there's also one part which really ties into procurement that could actually make the business case more attractive, and that is that the most circular thing that you can do is to not buy anything at all. So if we use the refuse and the reduce strategies, you can actually go towards cost savings. And that's what we did with one of these main office buildings of one of the large grid operators in the Netherlands, is that we didn't actually build a new building, even though that was what they initially wanted. We said, you have 8 existing buildings, let's minimize the amount of new resource use. So by thinking in terms of different questions and not looking at technical specs, you can actually create a magnificently circular building within budget. But I do agree that in many cases, it is the idealistic clients who just say, I really want this, so let's make it work. And we need the systemic change in order to make the business case more attractive.
Another question?
Hi, I'm starting to work with a creative network in my city to look at trying to improve the circularity of what we do as a creative sector. So I'm interested in how we as artists can be more circular in our resource use. So one of the sources of materials we could use is construction waste that's at a scale of sizes that can't be reused in construction, for example, but can be reused for other things. How do we begin to look at the waste flows that are available to us and start building something up?
Is it working? Yeah. Maybe I can give at least a partial answer to this. What I think is really interesting is to look at the urban mine, and then I mean it in the broad sense, so not just the built environment, but kind of anything that you can draw from our economy, our cities, our production systems, and see what type of waste flow is this. Is it really unique but very unpredictable? Then it's not something that you usually use at scale, but you can use it for a creative experiment, setting down a new vision. But there's also other materials like from industrial processes. For example, you saw the metal cladding that Superuse architects used on their building. I can know already years in advance, if I have good contacts with that producer, what will come out, and it's highly predictable. So those types of materials are maybe especially interesting to look for a design that you can apply at scale and to really do industrial design. So I think starting to think about not just what specific material do I have, but what type of material do I have here and what type of system is it released from, can be a nice starting point to say, oh, I'm going to make something really unique, temporary art installation because this is a one-off type of thing, or I'm going to look for an application that is more long-term, more scalable, because that's actually the resource that is being released here, and that's a really nice fit. So that might be a starting point.
Cecile?
I just want to add to that more in a call to action kind of way, because I actually think that artists have a huge role to play in the transition, because, you know, even listening to all of our stories, it's very fact-based, data-based, and we can only reach part of the population with these factual stories that are in words. And I think that we actually need art in order to communicate to other people how important this transition is and also how cool it can be. So just keep up the good work.
Well, and maybe as a small addition to that as well is that if you can't use it in the same function again, in the same industry, so windowsill as a windowsill or whatever, then actually the best next use application is maybe in a different function, but still in the same form. And that, I think, is actually where a lot of creativity comes into play. Like, maybe our solutions that we found thus far aren't as creative, but for example, we're now using old railroad tracks or starting to use them as construction beams and as columns, or using railroad sleepers as anti-terrorism blocks, which are becoming more and more popular these days, unfortunately. But I think it's actually a very exciting space where perhaps the creative industry can sort of jump on and look at new sort of creative ways to use old existing products into totally new, crazy function. And actually with that, be a sort of a lighthouse to the rest of the world, like, and saying, hey, look at what we can do, and then maybe the rest will follow.
Marco?
I think it's exactly what also Cecile mentioned, that we use art to promote the topic. I think last year we promoted the Cradle to Cradle topic on the Wacken Heavy Metal Festival in Germany, where hundreds of thousands of people come together. And I'm happy to connect you with my colleague who was there. Sure, he had a very nice experience, and I'm always keen to know what he did, actually.
Can we have two more questions? Who put their hand up there? Hold on.
Hey, I just wanted to say, you can do that exactly now. You don't need any of these organizations. There's a plethora of online free reuse networks that you can just avail yourself to. Yeah, and zillions of artists already do. Huh? Oh, well, there's Freegal, there's Enviromate, there's Salvo, there's Gumtree. You know, you can do this already And I kind of do what you're talking about. So I get all that stuff and give it to artists and festivals. And so half of Glastonbury, that is how they make most of their installations now. The whole of Shangri-La has a no buy new policy. You know, they even try to reuse their cable ties, right? So there's a whole movement out there of artists that are working in waste and have been for a really long time. I'll talk to you afterwards. Yeah, cool.
Kat helped me make the waste house.
Thank you. David Griggs, Environment Agency. First of all, thanks for all the talks. They're all really good. My question is, what's the single most important thing that city governments could do to drive this forward, make the change needed?
Brilliant question. Marco, we'll go Marco through. Everybody can have a go.
Well, I think there are already some pressures and regulations coming from governments. I think especially in the Netherlands, there is a huge pressure. And I think what we want to, or what we are currently discussing with governmental bodies is that a building should only get a building permit if you have a recycling strategy from the start. And I think that's what is going to happen very soon in Belgium.
It's a difficult question because there's a difference between the most important and the easiest. The easiest, I think, is procurement, but the most important, I think, does lie in regulation. I think it's really important that cities, because if you look at national governments, there's a plethora of other, tools that you could use, like fiscal incentives. But if you look at local governments, I think it's really about looking at the regulation that you have at a local level that can actually limit circularity, and to change that, because you want to create the legal space to actually facilitate circular initiatives to grow. So that would be my number one.
Yeah, I think for me it's a bit about opening up these types of insights and ideas that we've talked about, and maybe literally also opening up the models and the data behind them to a much broader group of stakeholders. An urban mining model like the one that I presented is not so interesting if I get it and I see the potential, but I can't speak to anyone in the sector or civilians or this whole network of stakeholders around it. So I think if, and building materials is just one example, but if cities want to be active stewards of the urban metabolism, that they actively want to govern their resource flows in a much better way, then that's never a top-down action or a kind of closed-down blueprint program, but it's much more about opening up all that insight in what is going in and out of the city on a daily basis, what is happening in the construction sector, what does the food waste chain look like, to a big range of stakeholders, and then getting new ideas and new business models and new applications out there and combining that in a really smart way. So I would say open that up and kind of go for an open source, more democratic approach to also the data and information behind this whole transition, because then it can go much faster.
Yeah, I'm looking at it maybe from a little different perspective. I showed you that roofing membrane that we developed, and of course I want to have it certified and I want to give guarantee on it. But if you look at the different membranes that can be certified due to European regulations, bitumen can be certified, PVC can, EPDM can, TPO can, but nobody in the world heard about a PVB modified roofing membrane. And if I go and ask for an offer, people say, then we have to change the regulation. But to change the regulation, you have to get the okay from all the other suppliers of different compounds. So let's say from our competitors, and they say, hey, that is what we are going to block. So maybe to answer your question, it might be good for governments, local governments, to also accept products that do not have the right certification, but a good story.
One of the things that we're currently working on, and may not be the best thing to work on right now, but is to make resources passports mandatory. And I think it's already now on the table, at least at a Dutch national level, but also through one of the law firms that we work with, also happening now at an EU level. Because what we see with a lot of our clients is that they have no clue what kind of materials they influence with their business processes. And really, we feel like that where everything starts with is good data management, basically. And by making it mandatory, we at least make it a little bit easier to find high value matches, and also help companies make much better decisions about what to do with their materials. Maybe not buy them, right? Or buy them in such a way that they have the lowest impact. Like, for example, now we're trying to look for a high value next destination for really sturdy wooden crates being used to transport medical equipment with, and they could actually be used to build a house. That's how sturdy they are. But it's been already a month for us to try to find out if there's formaldehyde in these wooden crates. And if they would have had a passport, we would have known that already beforehand, but now it just takes forever. And, with these things, if they take too long, they'll just end up in the oven, and that's just a real waste. So that's what I would also...
Okay, Kat, you had a question still? No. One last question, here we go.
Hiya, thanks for all your talks, they were great. I'm a garden designer from a small social enterprise, and we're based on a large regeneration development, housing development. We have a plethora of materials to kind of access, but we kind of struggle to get the developer to take us seriously at times. So it's kind of asking about like how you get those big developers to kind of take those like conversations seriously and to actually procure the contracts after that. At the moment, we're going into installations for garden shows and things like that to try and like showcase them. But have you got any other ideas?
Oh. How do you get contractors to take you seriously?
Well, I think it starts that you specify it in their contract already.
We lost the sound.
I think it.
Hello? Yeah.
I think it starts with specifying those requirements in the contract with the contractor. So if the contractor has this obligation in his contract, you can force him to do so. So this is principally always a good point. And it's always good to have already objectives and targets at the beginning of a project. That's something we are doing now when we sit together with an investor. We define a target, for example, regarding the recyclability of our project, and then we can always refer back to that. And if a contractor is not willing to perform against that target, he has to explain it principally to the investor who is paying the project. That's how we often.
But it's what we sort of call a chicken and egg situation, isn't it? What was it? Legislation or some ambition at a national or regional scale that enabled you guys to do what you do?
I think, and I think I speak for Gerard as well. We were working on this far before the government decided to make a national plan on the circular built environment. That actually only happened 3-4 years ago. So the only thing I would like to say, because of course it's very difficult to get the recyclability in a large contractor technical specification, if you're not speaking to the right person. And I think when I started my first building project, I think I was like 28 or something, even younger maybe, thinking who am I to challenge this demolition decision? But I think that in the end I found the person who actually agreed with me. And finding the right people is key in any project. So I think that what I'd advise, and it's really silly maybe, but to look on LinkedIn and to look for the sustainability advisor who is passionate about this topic, and kind of create the snowball effect from there. Because with just the first technical expert at this contractor, you're probably not going to get them excited, but maybe through an internal route you can.
Maybe briefly to add to it from a personal experience, I'm at the moment engaged in what's a bit of a different project, but building an apartment complex. And for a large part of that, we want to actually harvest materials from other buildings. And the first time we came with that proposition to the contractor, they said, oh, that's great, but then the risk percentage for this whole project is going to double. And that's just that, because it's a really overheated construction market. We already had the feeling, oh, this is going to be difficult because asking for less money in general is tricky if you make things more complicated with your whole let's do circular materials and harvest some things of which we don't know if they're going to appear, but we can find them. Then, of course, that doesn't help. And the trick there was actually to say, okay, fine, you find this more difficult. We don't want to spend more money. Let us solve it. We give you the guarantee that we take care of the logistics, the harvesting, the certification for FSC wood, all of that stuff. And if we can't do it before the deadline in your construction process, your call, you buy some new stuff. And we can't argue with that, but you give us until the deadline. And then if we solve your problem, there's no need for risk payment. And if we can't solve your problem, then you can do it your way. So I think meeting halfway and trying to work with them actively, especially in the early phase of the transition, is really helpful, because then you spread the risk and it gives you a bit more legitimacy to ask for something different and something which is maybe difficult.
Cecile's got a point.
I think you should add that this is your future home. So he's actually not doing this as a consultant, but as, he's involved in a different way. So I think it's similar. Sorry.
Yeah.
Okay, one thing I'd like to add to that is I think in the UK we are in a really interesting situation. We're poised just at the brink, because 75% of our local authorities have declared a climate and ecological emergency. They haven't just done that, they then said they're going to be net carbon zero in a decade, which is probably impossible. But we're in that situation where a lot of people are saying, what do we do next? A lot of people that are in positions to commission people to construct stuff, whether it's roads or whatever. And last Friday, the fourth runway at Heathrow got put on hold. We are in a really different place, and I think there's a partial vacuum there for people like you to take advantage of that situation and find other people who've got a similar sensibility to all of us to help you out. These are different times from this time last year. On that note, I just wanted you to give these guys a round of applause, because they're stars and inspiring us all.